Hello, 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 and welcome, ladies and gentlemen. Root Beer here with another Waterloo Math Contest. Which contest, you ask? The 2003 Euclid competition. So that's the grade 12 level math competition. It's a written competition. And 2003 was a very special year. The previous year, 2002, in Ontario, they had what was known as the double cohort. We finally got rid of grade 13. And there had been a grade 13 level sort of written competition, the Descartes, and that there was no need for it anymore. No grade 13, no need to have a Descartes. So they axed the Descartes, and they introduced three new competitions, the Friar, Galois, and Hypatia. And those ones were written competitions aimed at grades 9, 10, and 11. And now the Euclid was no longer sort of the prelude to the Descartes, the practice paper before the Descartes, before you wrote the Descartes the next year, during your last year. Now the Euclid was the last competition. It's the big one, the scholarship competition. So this is the first real year of the Euclid as we know it now as the scholarship paper. Okay, so big year 2003. It's also a competition that I remember fondly because this is the first Euclid that I ever actually wrote. I mean, I'd written practice Euclids before through my math enrichment program, but this is the first Euclid I actually sat down in my high school and wrote. And I always remember because of this question right here, this diagram with the helicopters always sticks out in my mind. I always remember this one. This was also, and we'll probably get to it in the very first question, because that's what we're going to be doing in this video, I didn't know what a parabola was, because I had sort of was it parabola? No, it was quadratic. That's what it was. I didn't quite know what they meant by quadratic there because I had only sort of just been going through grade 10 level math there. And so I remember having the proctor was a friend of mine, so I didn't mind asking him. And he said, well, it's, this, but I can't really tell you much more. So he was being a good proctor. Gave a little information, but didn't help with the actual competition. So that's right, we're going to be going through the Euclid 2003 now. So if you want a copy of the contest, you can get a copy by clicking the link in the description. Just like with all my videos, it's going to take you to the CEMC website. You can get a copy of this contest, you can get a copy of their solutions, or you can just stay tuned as my videos come out, and we're going to go through all the questions. So not much to say. If this is your first Euclid, then welcome. Time limit is 2.5 hours. That's something to note. Calculators are allowed, certainly. There are two symbols, sort of a light bulb idea question, and those are for short answers. All you need is the final answer there. And then these sort of writing on a piece of paper pictures, these require full solutions. So if we take a look, we're going to be doing question 1 in this video, as I said. Parts A and B are light bulbs. We would just need the final answer. And part C here requires a full written solution. Now, as I've done in all my other videos, I'm actually going to write out my explanations and my solutions here, so we're not going to notice the difference between the light bulbs and the written style answers, but it's something that you should keep in mind. Right answers for the light bulb questions, sure, for part marks, in case you get the final answer wrong, but don't spend too much time, because the written questions, so like part C, those are the ones where you really need to focus your attention. Okay. So let's jump into it. Question number 1, a three-parter, as we can already see. A. In the diagram, the parabola cuts the y-axis at the point 0, 4, so there's the y-intercept, and cuts the x-axis at 2, 0, and 4, 0, and passes through the point A8. Okay, what is the value of A? All right. So, there are a couple ways you could go about trying to solve this question. Now, it's 1A, so if you're thinking of a really complicated way to do this, then, that's fine. If it gets you the answer, that's good. But 1A, there's probably a very quick and easy way to do the question. And that would be by noting that parabolas are symmetric. There's a line that runs right down the middle of the parabola, and it's symmetric. It looks the exact same on this side as it does on this side. They're mirror images. So if we can just figure out where the center is, well, we know that 0 is at a height of 8. We have that in the picture here. And so we would just need to make sure that 0 is the same distance to that center line as A is, and that'll help us figure out what exactly A is. So, what is that center line? Well, we've got these 2 points here, and they're also at the same height. So they must both be the same distance away from that center line, and we can work that out. So let's actually go to the notepad. So, draw ourselves a little bit of a picture here. Parabolas are symmetric about this center line here. And we've got 0, 8 here, and we have A8. Let's use green. So this center line, it's going to be x equals some value. We don't know what it is yet. But these two have to be the same distance. And these two have to be the same distance from that center line, because they're at the same height. Okay. So it's going to lie halfway between 2, 0 and 4, 0. And so it's going to have equation x equals, well, it's halfway between 2 and 4. We just average them out. 2 plus 4 is 6, divided by 2 is 3. So this is the line x equals 3. So A8 is the same distance from x equals 3 as 0, 8 is. So A minus 3, so the difference in the x coordinates must be the same as 3 minus 0, the difference in those x coordinates. A minus 3 must be 3. And so A is going to be equal to 6. Now, if you can do that quickly, if you can do that in your head, just put it in the box that is provided in the answer booklet, and you can move on. If you want to, you can write down a little bit of justification. You can draw yourself a little picture. You can write more than I did, less than I did, whatever you think counts as justification for A equals 6. You can even write nothing at all if you're really confident in your answer, because it's a light bulb. That's the advantage of those ones. Okay, B part. The quadratic equation x squared plus 6x plus k has 2 equal roots. What is the value of k? So just like in A part, A part we had a really quick way of doing it, the one we showed. The really bad way of doing A part, I would say, would be to any 3 points determine a parabola. You could whip out the general equation for a parabola and try and work out what the equation of the parabola is, and then plug in A and figure out what value gives you 8. That would be a bad way to do A. So that's going to be a lot of calculation. In the same way, there's sort of 2 ways we can do B. We can do B by sort of completing a square here. Because if you have 2 equal roots, then that means that this quadratic is just going to be some linear term squared. Or we could bust out the quadratic formula. Both are perfectly acceptable ways of doing it. The quadratic formula one, I think, is going to be a little longer, but not nearly as long as, say, the bad way of doing part A. So, I don't know which one I should do. I mean, if it jumps out at you, you're going to complete the square by doing, 9. You'll complete the square by doing this, and then you'll realize, well, this is going to be x plus 3 squared, and this is going to have to be 0, so then k equals 9. So that's one way of doing it. Or you could just say, well, this sort of looks like it's a square, k is going to have to be 9. But let's do it sort of the longer way, because I think this is the one that most inexperienced people will do just based on instinct. So, we have a quadratic here. So if we want the roots of this equation, we use the quadratic formula. That's negative b plus or minus the square root of b squared, so 6 squared is 36, minus 4 times a, which is 1, times c, which is k. So minus 4k. All over 2a, so that's just going to be 2 in this case. Now, if we want two equal roots, we're going to have sort of plus and minus a 0 over here. This is the only way to get two equal roots. If you had a 1 over here, you'd get negative 6 plus 1 over 2. But that's a different root than negative 6 minus 1 over 2. The only way you can do it is 0. So that tells me that 36 minus 4k, square root of that is 0. Square both sides, you get 36 minus 4k equals 0. And from there, we also conclude that k is equal to 9. Okay. So that's another way you can do it. If you are really good with completing the square, if you can just do this in your head, that's great. But quadratic formula always comes to the rescue as well. One thing I try and get across to people is the quadratic formula might be a little longer, but it is nearly consistent in its length, and it always gives you the roots. So you can try and factor things in your head. You can try and complete squares, but if that takes you too long because you're not thinking of the right factors, you can waste a lot of time. Okay, so that was b. Value k is 9. Now C part, where we would need to actually bust out a proof, a written explanation, some justification here. The line y equals 2x plus 2 intersects the parabola y equals x squared minus 3x plus c at 2 points. One of these points is 1, 4. Determine the coordinates of the second point of intersection. Okay. So what can we do here? Well, if 1, 4 is a point of intersection, then that means that 1, 4 is on both this line, which we can tell, 1 plugged in for this x. 2 times 1 is 2, plus 2, it's going to be 4. But it also means that it's on this parabola here. And this parabola has this c value that we don't know what it is. It'd be really nice if we knew what that c value was. Okay. So what I'm going to do first is I'm going to take x equals 1, plug it in here, keep this c around, but I know it's going to have to equal 4. And then I can work out what c is. So let's find c. So 1, 4 is on the parabola. So y was x squared, I think it was minus 3x plus c, but let's just double check. Yep, minus 3x plus c. Good job, brain. So 4 is 1 squared minus 3 times 1 plus c. That's 1 minus 3 plus c, or c minus 2. Bring the negative 2 over. We get c is going to be equal to 6. All right. And that means that our parabola is y equals x squared minus 3x plus 6. So, why did I do that? Well, now that I have a parabola and our line, what we can actually do is we can intersect them in the usual way. We can say, well, 2x plus 2, the line, equals the parabola. They both have the same y-coordinate for the same x-coordinate. That means we can set these equations equal, and we can start solving for x. Now, one of the values of x is going to be 1, because we're told that 1, 4 is on this parabola and on this line. It is a point of intersection for both of them. And that means we'll very easily be able to pick out one of the factors here. So let's bring everything over onto one side. X squared, we have a minus 3x minus a 2x. And then we have plus 6 minus 2. So x squared minus 5x plus 4. And we know that x equals 1 is going to be one of the roots. So we're going to have an x here in order to make x squared. And then in order to get plus 4, we're going to have minus 4. And minus 1x plus minus 4x, that does give us minus 5x. So we've done the right thing. So x equals 1. We ignore the 1 because we already have the point of intersection for that one. X equals 4. And y is 2x plus 2. So that's 2x times 4, or 2 times 4 plus 2. That's going to be 10. And I was asked for the other point of intersection, right? Determine the coordinates of the second point of intersection. So the other point of intersection is 4, 10. Now obviously if I plug in 4 I get 10 on the line. If we wanted to, we could double check just mentally what happens when we plug in 4 into our parabola. 4 squared is 16 minus 3 times 4, so 16 minus 12. That's going to be 4. Plus 6 is 10. Congratulations, we got it. Okay. So, that does it for C, and we have explained what we were doing. We found C. Then we set our parabolas equal. We got 2 possible x values. The first one, the 1, was already dealt with. X equals 4 is that other one. And that works out to give us the other point. Okay. So that does it for question 1 on the 2003 Euclid. Again, download a copy of the contest. Try it for yourself. Try to figure out the answers to each question before you see their solutions or watch my video solutions. And that way you can really tell whether or not you're really getting it. Okay. In the next video, we're going to do question number 2, which has that, he's a goat, a lazy stationary goat, and the helicopter. So we're going to get to that, which is the question I always remember, but we're going to get to that next time.